What's up, guys? Today we are going to be taking notes on Chapter 6, Section 3, Linear Functions. Alright, so let's start it off with our first key idea. So our first key idea says that a linear function is a function whose graph is a non-vertical line. A linear function can be written in the form y equals mx plus b, where m is the slope and b is the y-intercept. So a vertical line, if we remember, vertical line is any line that goes up and down. Makes a vertical line on the graph. Let's see. Okay. So any vertical line on the graph will have the equation x equals, and this line would be x equals 2. If it was x equals 2. If it was over here, it would be x equals 5. X equals -3 if it was over here. So this is a vertical line. Slope dude told us that this has a slope of that is undefined. So any vertical line is not a function. Oop, I guess the pen's not working for me right now. So any vertical line is not a function. A vertical line is not a function. So let's think about what lines would be a function. Well, y equals mx plus b. Any line that could be written as y equals mx plus b would be a function. If you remember, m is our slope, and b plus b is our y-intercept. Okay? So, any line written in y equals mx plus b will be a function. So let's just use the line y equals, we'll do 2x plus 3. So y equals 2x plus 3. That'll give us the y-intercept at 3. We go up 2 over 1. We can go the other way as well. Down to -1. Down to -1. And then we connect our points. Use the line tool. So this, any line that can be written as y equals mx plus b, will be a function. So this is a function. This one is not. A vertical line is not. So example 1 wants us to use the graph to write a linear function that relates y to x. So I took all of our points that we had on the graph and wrote them out over here as ordered pairs. We could see that these points on the graph would create a line if we use our line tool. And go right through all of them. Just like that. So if we use our line tool, go right through all of them, we get a line. What this wants us to do is to write the equation of this line, the line that it creates. This is a function. So the first thing we have to do is find our slope. We remember m is our slope, and we can find it by doing y2 minus y1 all over x2 minus x1. We plug in our y's and our x's. First, we have to pick 2 points. Let's pick these 2 middle points right here. Okay? So we'll do -3 minus 0 all over 0 minus 2. Okay? We solve that. Bring it down here. -3 minus 0 is -3. And 0 minus 2 is -2. -2. And we know a negative divided by a negative is a positive, so this turns into +3 over 2, or 1.5. So now we have our slope. If we look at this line, we see that it crosses the y-axis at the point 0, -3. We see anywhere that x is 0, this will be our y-intercept. So let's write this as a line. It's y equals mx plus b. So y equals, our slope is, just plug in our slope, 1.5, x, and our y-intercept is -3. And that's it. That's our final answer to example 1. Example 2 wants us to write a linear function using a table. We're going to use the table to write a linear function that relates y to x. So first, we can write all of these as ordered pairs. We have -3. All of our values from the table can be written as ordered pairs. -3, 9, -2, 7, -1, 5, and 0, 3. Okay? Now, first thing we have to do is find our slope. It's the same thing we did in the last problem, except we're using a table now instead of a graph. First thing to do to find our slope is y2 minus y1 all over x2 minus x1. We'll pick 2 points. We'll do these bottom two. We have -1. I'm sorry. It's y's first. We have 3 minus 5 all over 0 minus -1. You can pick any points in here. It doesn't matter. You'll get the same slope. So 3 minus 5 is going to give us -2 over 0 minus -1. Remember, when we subtract a negative, it turns into a positive. So our denominator will be 1. This simplifies to -2. Okay? So our slope is -2. Looking at the table and our ordered pairs over here, we see that at this point, when x is 0, y is 3. This would be our y-intercept on the graph. When x is 0, y is 3. So, to write it as our equation, y equals mx plus b, we just have to fill in what we know. Y equals, our slope is -2, x, and our y-intercept is 3, positive 3. So our equation for example 2 will be y equals -2x plus 3. So example 3 is our real-life application. We're going to take everything we learned in example 1 and everything we learned in example 2 and use it to solve a real-world problem. So our problem is, you are controlling an unmanned aerial vehicle, or a UAV, for surveillance. The table shows the height y, in thousands of feet, of the UAV x minutes after you start its descent from cruising altitude. So basically you start flying a UAV, and the longer you fly, the lower it gets. So you start up here, you would start at a certain height. The longer you fly, the lower it goes in the sky. Okay? This table over here maps the height of its descent, or how much it descends after X amount of minutes. It's important to note here that minutes X is our independent variable, while the height Y is our dependent variable. However many minutes we plug in, we can plug in any number of minutes and that will give us the height. The height depends on the amount of minutes that it's been flying. So let's start it off. There's 3 parts to this problem. Part A says to write a linear function that relates y to x. Interpret the slope and the y-intercept. So the first thing we have to do is find our slope, just like we did in the last problems. So we use our table, our data table over here, and we plug it into our equation for slope. y2 minus y1 all over x2 minus x1. We'll pick the first 2 points for this one. So this will be 60 minus 65 all over, 10 minus 0. Well, 60 minus 65 equals -5. Over 10 minus 0 is 10. Negative 5 over 10 reduces to negative 1 over 2, or negative 0.5. So our slope is going to be negative 0.5. But what does that slope mean? So the slope is negative 0.5. The slope indicates that the height decreases 500 feet per minute. After 1 minute, it decreases 500 feet, because we remember our height is in thousands of feet. So half of 1,000 feet is 500 feet. Okay, now that we found our slope, it's time to write the rest of our equation. When we look at our data table, we see that x is 0. When x is 0, y is 65. This will be our y-intercept on the graph. So this will be our plus b in our y equals mx plus b equation. So let's plug in what we know. Y equals mx plus b. So y equals negative 0.5 x plus 65. So our final equation to finish out part A of this problem is y equals negative 0.5x plus 65. But what it actually means is after 1 minute, it will descend 500 feet, and it starts at 65,000 feet. It's really important to watch that we're working in minutes, and the height is in thousands of feet. It's going to be even more important when we look at part B of this equation. So part B of this equation wants us to graph the linear function. Well, we can do it one of two ways. First, we could look at our data table from part A and just graph those points. I listed them over as ordered pairs here for you. If we just graph those points on the table and then connect the dots, we'll get our line. Or we could graph our equation that we found, y equals negative 0.5x plus 65. There are two ways to do this. We are actually representing this function now 3 ways. We are representing it as a graph, as a data table, and as an equation. So we have three ways of representing the same function. Now let's use this function to solve a problem for it. Part C wants us to find the height of the UAV when you stop the descent after 1 hour. Find the height of the UAV when you stop the descent after 1 hour. Well, let's look at this right here. Hour. We haven't been working in hours. We've been working in minutes. So we have to convert. 1 hour is equal to 60 minutes. We all know that. 1 hour is equal to 60 minutes. Now, if we plug in 60 minutes into our equation, we would find the height, because the height is the dependent variable. So let's try it out. Y equals negative 0.5, plug in 60 for x, because x was our minutes. So y equals negative 0.5 times 60 plus 65. When we solve this, y is equal to negative 30 plus 65, which is all going to be equal to, hang on, let me make some more room here, which is all going to be equal to, where's the pen? There it is. Y equals negative 30 plus 65 is positive 35. But positive 35, what does that mean? So after 60 minutes of flying, the UAV is at a height of 35,000 feet. 35,000 feet after 60 minutes. All right, example 4 is comparing linear functions. The earnings Y in dollars of a nighttime employee working X hours are represented by the linear function Y equals 7.5x plus 30 and the table shows the earnings of a daytime employee. So we have two linear functions represented two different ways here. The nighttime employee, which I underlined in blue, is y equals 7.5x plus 30. The daytime employee, his earnings are represented by this table. So first, let's take a look at the nighttime employee. The nighttime employee's equation is written in y equals mx plus b. But let's break it down. Y is his earnings. We get that from the problem. M, his slope, would be the wage. That's how much money he earns per hour for every hour that he works. X is the number of hours that he works. X is the number of hours. Plus, his B would be a bonus. So let's just say he gets $30 every time he shows up to work, and then he makes his wage. For every hour he works on top of that. So he gets $30 for showing up, and then makes $7.50 an hour for every hour he works. So let's write this out. So his earnings will be y. It's going to be equal to 750 times x, which is the number of hours that he works, plus $30. So he makes $7.50 an hour and gets a bonus of $30 just for showing up to work that day. The daytime employee, on the other hand, if he works 1 hour, he makes $12. If he works 2 hours, he makes $25. If he works 3 hours, he makes $37.50, and so on. So let's see, as x increases, does it increase steadily? We got to check all of these. So 1 to 2 increases by +1. 2 to 3 is an increase of 1. And 3 to 4 is an increase of 1. And then 1250 to 25. Oh, hang on, my pen's not working. There we go. 1250 to 25 is an increase of 12.5. Oh, hang on there. It's an increase of 12.5. 25 to 37 is an increase of 12.5. And 3750 to 50 is an increase of 12.5. So if we look at it, remember, to find the slope, it is his change in y over his change in x. So as time increases by 1, his change in y over his change in x is equal to, so his change in y, well, that increases by 1250 each time. So his change in y is 1250, and his change in x, it increases by 1 hour. So it's 1. So he makes 1250 an hour. While our nighttime employee makes $7.50 per hour. So the daytime employee has a higher hourly wage. But let's take a look at this in a different perspective. So, part B to this question wants us to write a linear function that relates the daytime employee's earnings to the number of hours worked. And then it wants us to graph it. So first, let's write the linear function. His earnings, the daytime employee's earnings, was y equals, his earnings were represented by y. His hourly wage was $12.50 times the number of hours that he worked. This is a proportional relationship, which means that it starts at 0. If he works 0 hours, he makes $0. Whereas our nighttime employee made $7.50 an hour, but had $30 just for showing up. Now the second part of this question says, in the same coordinate plane, graph the linear function that represents the earnings of the two employees. Interpret the graphs. Well, our graph over here has the nighttime employee in blue. His y-intercept was 30, and he's increasing by $7.50 an hour. The daytime employee, his equation is y equals 12.5x, but his y-intercept is 0 because it's a proportional relationship. So, what does this mean? Who makes more money? Well, it depends. The graph shows that the daytime employee has a higher hourly wage, but does not earn more money than the nighttime employee until each person has worked more than 6 hours. So right here, where these two lines intersect, our system of equations, where these two lines intersect is where they make the same amount of money. So after 6 hours, after working for 6 hours, they've both made the same amount of money. After working 6 hours, the daytime employee makes more. And before working 6 hours, so working 0 to 5 hours and 59 minutes, the nighttime employee earns more. Okay? But right here is where those two equations are equal. Alright, so that was Chapter 6, Section 3. I hope that was helpful. Don't forget to like and subscribe and comment below if you have any questions. Bring any questions you have to class. Alright, take care guys.